Yes, so we'll.
That's fine.
Yes, so there we go. You might want to mute the there we go. YouTube. You might want to mute the there we go. YouTube. You might want oh gosh, we got a loop. There we go. YouTube. I gotta figure out how I want to change that. Why can I hear that? Oh, because I need to mute it locally. Okay, here we go. Got it. Nailed it. All right, so yeah, you guys might want to mute that YouTube just so you can hear me through Discord. That'll be a little bit lower latency, and hopefully you guys can see the Visual Studio Code. True.
Yep.
Cool. Yep. Right on. Well, yeah, I mean, this is essentially my plan for class next week and moving forward. Well, I say class, quote unquote class, right? The in-person stuff. So yeah, actually, before we get into stuff, I mean, you guys got any questions? You guys got any concerns, comments, things you think I could do better?
So you're going to be posting these recordings after, like, if someone doesn't come to class?
Yes. So basically, I want to make sure that all of the stuff around class is available online, either afterwards or beforehand, right? Because I know there's some people in class that aren't in Pacific Standard Time, and so therefore that's going to be complicated if they, right? Like, I know Lisa Kamatad is in Thailand, and so it's like 1 or 2 in the morning right now for him, and so I don't want to make him deal with that. So yeah, I will be publicly listing these on that YouTube channel. I'm going to try to organize them the best I can. I think in Blackboard I'm going to have links to everything for each lecture, so I'll post a link to this video on Blackboard with everything else.
Okay.
Yeah, and that goal is so that if you can't make it for whatever reason or you just don't really want to, right? You can always grab it later. I would still suggest that you try to make it for each of our class periods, just because you won't have to repeat as much stuff, and I can help you directly.
And you can ask questions.
Yeah, exactly. Yeah, that's a big thing, right? I'm not going to have any structure for these class times. I'm just going to be available for whatever you guys want to work on. If that's going back over a concept from the lecture videos, if that's talking about recursion and the assignment that's due, right? My goal in this time is for you guys to kind of drive what we do, and so yes, I will be recording it. We'll post it afterwards.
Okay.
Yeah. So I see. This is another thing, is I want to make sure that you guys are okay with Discord, because I see Ethan is online but not attached. All right, that's right. Yeah, so what do you guys want to talk about? What else?
Well, so I had like all those questions from like Monday.
Yeah.
So I don't know if you wanted to do that now or like after, because it'll probably take some time.
We can get into whatever, right? I mean, I assume the 3 of you guys are all still working on the recursion stuff. Based on conversations with Zach, he's kind of near the end.
I'm very close to wrapping up the 8 queens.
Okay, cool.
And moving on to blobs.
Cool. Okay. And
so that's kind of where I'm at.
Nizama, where are you at?
Same as Ryan.
Cool.
Same as Ryan.
So yeah, let's actually just start really quick with 8 queens. Do you guys have any immediate questions about that?
No.
I mean, there's a lengthy discussion that Zach and Jude had in the discussion thread for PR4 about the complexity of queens, but that's a whole nother.
Oh yeah.
I mean,
it's like anything.
No, so you guys are on the right track. So I don't think I need to correct anything about what you guys are talking about. So I was just going to leave that as is, but we can get into it if you still have lingering questions.
I guess, well, so obviously my algorithm is horribly inefficient. I guess, like, what like sort of thing would you try to make it more efficient, like your recursive algorithm? Because the way I'm doing it with, like, it's pretty much like go in a straight line and then backtrack immediately if you have something bad, and that's pretty much brute forcing, honestly.
Yeah, it's a little bit more sophisticated than brute force, though. Right? Actually, so let's try this. I'm just gonna use PowerPoint as just a sketch tool. right? Because we could do this in Excel as well. So let's just consider this for a sec. So this is going to be a queens algorithm, and we need to make a table. So, gosh, most time I don't have people watching me as I make PowerPoints. 8 by 8. All right. This is a thing that I've become like oddly really good at. Very quickly, given what I have to do most days. All right, cool. So we got our chessboard, right? And so like one way we could do this is we could come up with all the different permutations. So we could put in, the very first permutation, which we know instinctively is not true, right? We know this isn't going to work because of all of the queens on the top. So then we could do something like, okay, brute force would be, okay, let's move this queen and let's put that queen down here. Right, and we know that's also not good because this queen is interacting with this queen. So there's this whole thing where there's a difference between a brute force method that is breadth first, or checking all of the possible first steps, and then a brute force algorithm that is depth first, which is going until you get to the very end and then seeing if it works or not. And so the recursive algorithm is essentially getting towards more of a depth first brute force algorithm. The problem is that you have to do brute force. There's not really a better way to do it because you don't know, you can't think ahead very efficiently in terms of like, oh, if I, the very first queen placement actually turns out to be the least optimal, right? If I get rid of all of these queens and I put a queen right here in this top corner, this is really bad, right? Like,
yeah, that's what mine does.
yeah, well, and that makes sense because you probably start at 0 and you just increment from 0, right?
Oh yeah, that also leads into another question.
Yeah.
So if we're incrementing and calling our function recursively, how is that not iteration?
Yeah, that's a good question. So
because that's what mine is doing that.
So let's do this really quick. So this is this is gonna be 8 queens recursion. Oh gosh, recursion. There we go. So if you think about like your function calls, you're gonna have I'm just calling it EQ for 8 queens, and you'll have 8 queens 8, and that's gonna call EQ 7, and that's gonna call EQ 6, right? So the recursion is that your 8th queen needs to call the 7th queen and the 6th queen. Does that help?
So mine is doing the opposite of that.
So you're going
it's
from
starting
0.
at 1 and calling 2, calling 3, calling 4. Is that the same thing?
Yeah, basically. So really quick, what's your return? Is it a bool?
Yeah.
So we got a bool, and we've got 8 queens.
So it's like if there's.
And then are you passing in an array?
So I have a function. No, I'm not passing in anything.
You're not passing anything in?
So. Yeah, so it's like what it's doing is so it's like the base case is if there's 8 queens, and then I have a function that checks if the placement is valid or whatever. So if that returns true as well, then obviously your base case is done and you return new, and then like the actual like recursive part is like it goes through trying to place something, and then it calls find queens again to see if that's true for that thing, like for that iteration. It's a little bit like complicated.
Well,
but
hold up. So is find queens your recursive function?
yeah, it's yeah.
Okay, so I think we can move that up. So bear with me for a sec. So let's think about this in terms of we have a Boolean return, we've got our function, and let's in this case say we have some n, and external. I'm gonna cheat a little bit. I'm gonna make some like char array that's gonna be 8 by 8. Now I'm saying I'm cheating because right, I'm gonna have to make this a global variable for this to work. Ideally, you would be passing this in as a reference variable, but that's okay. To keep the simplicity, I'm just going to keep this int n. So one way we can think about this is this function will return true if it could place a queen, if it could place the nth queen. So in this case, the placement of this queen in column 0 is predicated, like the successfulness of placing a queen here is predicated on if you can place a queen in the second column. True? Right? And so if we keep stepping forward, if I say, okay, I'm going to take a guess and put my queen here, I'm going to then say, okay, I'm going to put a queen here. Does that work? No. So this is going to return false. It then comes back to here and says, okay, great. I'm going to try to put a queen here. Does that work? No. Right?
Yeah.
So then we go forward and we put a queen here. All right, this is good. Now we have queen 7, if you want to count from 7 on the left to 0 on the right. And we have a queen in 6. Those are both pending. They're okay, but they're still predicated on everything beneath it. So now we're going to jump back into here and we're going to say, great, for this queen, can I put it here? No. Right? For this queen, can I put it here? No. No, no. Great, we can put it here. So these function calls for these queens are going to be hanging, essentially. They're going to be waiting for the queens beneath them to be called. So that's the recursion, right? Like the recursion is that for us to place the third queen, we have to know the placement of the fourth queen. But the fourth queen needs to know if it's good or not, if it's a good placement or not, based on the queens that came before it.
Right.
So if we think about our algorithm, our base case is going to be like placing last queen, last queen, and our recursion is going to be like try new place for queen n-1. So really what I might want to do is I might want to put in an n, which is essentially going to be our column, and then into row, which is going to be where we want to try to put that row for that queen. So if we go back to here, this queen would be, we'll be counting down, so 7, 6, 5. So this is queen 5 at row 0, 1, 2, 3, 4. And this is going to be queen 6 at row 2. And this is queen 7 at row 0.
Oh, right.
So then,
Why is it?
go ahead.
Why is it queen 7 and not queen 1?
It doesn't matter. You can go the opposite way. If you start at 7, it's a little nicer because then whenever you place this one, it's going to be queen 0 at row, right, whatever. And then that's a very easy base case to check for. All you have to do, I don't know why I keep alt-tabbing. All you have to do here for your base case is say, if n, well, we can just say if not n, right? But to be clear, I'll say if n is equal to 0, we need to have some check if placement is good, and then return true. So if we're starting at 7, then we know that this 0 with queen, all we need to do is just verify if it's in the right spot. We don't need to keep going. Does that help? You could go the other way and then compare, like, if n is equal to, like, max queen, but now max queen has to be a variable, and that's a little more complicated. The short answer is it doesn't matter. It can go either way.
Huh. Okay.
So,
Yeah.
if our else here, right, else placement is not good, we're going to return false. And for our recursion now, we can just say, if placement of queen n is bad, return false. We know that we don't need to check anymore.
Right.
Placement of queen and his
授業やってんの
oh and his amu. Then check. Nope, that's not how you spell queen. Queen n minus 1 at some row.
Mm-hmm.
Is this helping?
Yeah.
Is
think
it
so.
just not what you did for your solution?
No, mine's kind of weird. So.
So you can kind of this problem can be solved iteratively if you have basically like a marker for each queen in terms of where queen 7 is, where queen 6 is, where queen 5 is. Right, you can do this not in a two-dimensional array and instead do it using just a like having two numbers associated with each index, right? There's lots of different ways you can represent the data.
Mm-hmm.
Yeah.
Yeah, mine was mine was kind of weird. Like what it would try to do, like so we would start at the 0th like element or whatever in the array, and then it would see if it could like place like I use like character Q as a queen and then like zeros
Yeah,
or
sure.
something as like
Sure.
nulls. And it would so it would like check the first element for a Q, and it's like, okay, if there's not a Q there, place it down, and then it would call the my placement, I guess. Well, no, it would like recursively call itself, so it would be like if it's true, then it would like skip over it, but if it was false, it would like go back and do. That's not a good
Yeah, no, I
explanation.
get where you're getting at, and really, it's in this. It's here, right? When I have here the placement of the queen is good, and you check queen n minus 1 r. Really, what this is this is a if 8 queens n minus 1 of r, and this needs to be like a for loop. I mean, don't use 8. That's a bad coding practice. Right, so we're going to go through a loop, and this loop is essentially going to be checking every single possible position, right? First we're going to check that one, then we're going to check that one, then that one, then that one, right? We're going to work our way down this row. And for every one of these, if this ends up being true, then that means it, n minus 1, is going to check its n minus 1. So if we find out that like this is a valid position, which I think it is for right now, right? Then this Q, which is Q 4 1, then this one is going to then check a Q here. Oh, not exclamation point. Right, and so this is where we get into the whole call stack, where we're going to have a bunch of pending calls in the if true, and if it is true, the collapse is going to come. I'm just going to put this all in one line. Right, we'll just return true. Else, we want to keep going through this for loop.
Mm-hmm.
And then if we don't make it through that for loop, then we can return false. Right? If we've exhausted all of our other possible checks, then we can stop.
Yeah, mine kind of does that too.
Yeah.
As I return
So I mean,
false.
you might be on the right
Okay.
track, right? I don't want to dissuade you from where you might be if you're feeling good about it.
Yeah. I'm feeling
I
fine
know
about
what
it.
mine does is I have it check each queen as it's placed down, and if it doesn't work, it takes it back and checks it again, and then if none of them work, it goes back further and then comes back to see if more
Yeah,
work.
yeah. That's
Yeah, backtrack.
yep. That's the
right?
backtracking. Yeah, so
Yeah.
that's good. Yeah.
Yeah.
And this is where like the complexity conversation gets complicated, is because right, the backtracking is not intuitive.
Yeah.
Yeah.
Yeah, like I noticed like once I got to the 8th queen, that's where the number of operations spikes up like insanely high because like placing the first 7 is pretty easy because it's just like if you just go into a new column or something, you can just do
Yep.
that. But once you get to the 8th one and something doesn't work, you have to backtrack 1 back to 7 and then try all that again. And then if that 7th doesn't work, you gotta go back to the 6th, and it just goes all the way back. And yeah, so
All right. Other comments, questions, concerns on 8 queens? I can also pull up your code if you guys want me to.
No, it's
Okay.
fine.
Okay.
I don't think I've pushed mine yet. That'd probably be a good
Well,
idea.
I mean, if you want me to see it.
Well, just to save it,
Oh, yeah.
just in case something weird
True.
happens.
True.
So it was just I had to reset up my VS Code on my laptop. It was like freaking out on me. I had to like uninstall it and then completely reinstall. But it's working.
It's working
It's
now.
working
though?
now,
Okay,
which I'm good.
I was just saying, okay,
Yeah.
we can figure that out if you want.
Took me a while, but VS Code's always finicky on my laptop.
And that's part of what I want to get figured out this week is making sure those kinks are ironed out, just because it's going to be good to know. All right, I'm just going to send a message to these couple people that are hanging out and not actually part of the call.
if anyone needs help getting VS Code on Windows, I've set it up like 20 times, so. Because I'll keep going to the lab and someone will be on the computer that I was using. It's like, time to try to use a new one.
And I also tried to implement a random for the first queen, so that it'd start in a different place each
Yeah.
time.
Hey, Josh.
But with the backtracking,
Yeah,
it usually only starts in a small handful. Of
yeah.
places.
So this is a good point. So in the conversation Zach and Jude were having yesterday about this like idea of what is the complexity of this algorithm, if you introduce random placements, it gets a little different. And it doesn't necessarily make it better,
Yeah.
but it's possible that you can stumble into a good path. And how did you determine your random placements?
I just did. Well, I only did random placement for the first one, so I could get different
Oh,
outcomes.
okay.
For
So
the
really
rest
you
of
can
it.
only get 8 outcomes. True.
Yeah.
Well, possibly
Yeah, I think
possibly
so.
less, but yeah.
What do you mean 8 outcomes?
Currently, I have less than that, but I only ran it like 2 or 3 times.
Yeah, so
and
and Ryan, correct me if I'm wrong, but what you're saying is right. Like right now, if we go through the way I have this algorithm set up, we will hit the same solution every time because we're always deterministically starting with our first queen at the one corner. But
Yeah.
if we arbitrarily say, well, no, let's just put our queen down here, right? I don't know if this is the answer, but I'm just going to guess and say that it's what 0, 1, 2, 3, 4, 5. And then we go from there. Then it gets a little more interesting because then this next queen, this next queen that I can check, I can in fact put it up here in the top row, right? Queen 6 can go there. And so it's just getting towards this idea that if you seed your random placement, then that means you're going to get different answers. So it's possible that you can actually seed the placement of every single row, and then that means that you will get a lot less determinism in your answers.
Yeah, and I'm getting pretty similar answers for most of mine, but like a couple of them are changed.
Sure.
Like, I haven't fully tested out they work, but I tested it out on the first round, and I'm pretty sure my algorithm works. I need to like test through the ones that have popped up on VS Code to see if they actually work or not.
Yeah. Yeah. All right, Josh, you had a question?
Did you see it on the YouTube
I'm pulling
thing?
for the quick. So are we shooting for this to be on one CPP, or should we have an H and a CPP? That's a good question. No, you can have this all in one, right? Because ideally, you only really need like 2 or 3 functions for this program.
That's what I was thinking.
Yeah.
That's what I had
If you
the first
if you
time.
develop some like complicated class to help you do this, which you can, there's actually a decent. You can make like a board that has like internal checking for placements. That's fine. If you do,
That's kind of what I was
Okay.
doing. I had it as like my .h and .cpp was making the chessboard.
okay,
and
yeah,
It kind of like goes through and finds if like the valid position is there and changes the chessboard piece to a 1 if it was a 0 or something
Okay,
like
yeah.
that.
So yeah, if you have a class, I would make the class separate files. But other than that, no, I wouldn't. It's okay.
Oh,
Yeah.
okay. Okay.
You should still do proper code formatting, right? You should still like comment your functions, and you should still, right? All that still
Mhm.
applies. You just don't need to necessarily get deep into pulling it out into separate files.
Okay.
Cool. Okay.
I
Yeah,
don't.
go ahead.
Oh, I have this like huge function like in my class that I use for testing, but I'm not gonna use it anymore. Do you still want it in
No,
here?
that's a good question.
Because it just takes up like 200 lines or something. Because it's just
It's up to you. You can put a comment around it saying like, I'm not using this, but here's some work. That's fine.
okay. I'll just do
Yeah.
that.
I mean, is it like a bunch of out statements?
Yeah,
Yeah,
essentially.
sure. That's fine.
It was yeah. It was like my checker, but it like wrapped around that was like printing out like X's where the illegal spots were. So it's just for visualization, pretty
Yeah.
much. Okay. Cool.
All right. Other questions on A Queens?
No.
Okay. Do you guys want to move on to blob detection?
Sure.
Okay.
Is it okay if I share my code with you?
Yeah.
Maybe
Well,
later?
actually, I mean, if you want, I can pull it up now, or we can look at it later. I don't care, right? It's more of if you want to not have everyone look at your code, I don't have to pull it up now. I can look at it later. But if you want, I can pull it up right now and we
Yeah.
can talk through it.
Well, because I don't know how much time that's gonna take. So
We'll see.
if it works
Yeah.
better.
We can keep going. We'll come back, and if we got time, we'll go into it.
Okay, I'll just push it for right now.
Yeah. That'll be good. All right, cool. So, blob detection. Let's make a new slide for this. So, blobs. Actually, we can duplicate this.
So
Yeah.
Scott, are we recording the live streams and are you gonna just put them on the YouTube channel so if we can watch them later or something
Yes.
like that?
So we're doing that currently. It'll be
Okay.
essentially this will be posted after we're done here, and it'll be public, and you can grab it. Which is also why I asked the question: are you guys okay if your voice is also being recorded? Because it's a little more permanent. I'm okay if you guys don't want your voices recorded. It just makes it a little bit easier on my side, so I don't have to like repeat your questions to make sure that my voice is contextually relevant. But
I mean, probably easier on us too. We can go back and really check anytime.
and we'll figure that stuff out too. I don't want to plow too hard ahead into just like we're gonna do it this way, but yeah, we'll figure it out.
Yeah.
All right, so for blobs, this one is a little. Both of these problems, the 8 queens and blobs, become extremely simple once you understand what the recursion is. Understanding the recursion is non-trivial, right? I'm not suggesting that that's easy, but once you understand what the recursion is, I don't think they're too bad. So for blobs, you're going to have a for loop. You're going to have a double nested for loop that's going to have to go through and check every single cell of your array. Now, you could do this recursively. It turns out that the for loop is pretty straightforward and the recursion is extremely straightforward. So don't worry too much about that. But what you will do is you will call your recursive function. So blob algorithm. You're going to call your recursive function. This is going to be blob. Probably, I'm going to just give you a hint really quick. This should probably be an int. And your blob is going to be probably some row and some column. That's just my suggestion for right now. So you're going to have a for loop that's going to call, right, like blob 0 0. Now, when you look here at 0 0, there's no element here, so we can just move on. So the very first thing we should probably check for our blob is there something to check? No. Return -1. Yes, this is going to be where we get into our recursion. Recursion. There we go. So when I check this, there's nothing to check here, so I just move on. I then move on to blob 0 1. Nothing there. Move 0 2. Okay, great. But eventually we're going to get here to blob 1 1. And at this point, we know that there is a blob we need to detect, and so we're going to start doing the work, right? We're going to actually start doing the recursion. So we'll call blob detection on 1 1. Now, the base case is going to be what? Do you guys know?
That you're at the last element, and they've all been done.
Maybe. There's a simpler base case though. Because how do you, like, let's say I truck my way down, right? I start working. I need to put some arrows in here. These are gonna be helpful. Oh, not pictures. Go away. Shapes. Right. We start trucking our way down our blobs, and I'm checking down here. How do we know that this is the last cell? We don't really. Right. We only know that this is the last cell because we've checked here in 0.
Mm-hmm.
Well, I'm confused. Your index has to be. You have to be at like index 2020, and then you're done.
Maybe. So you're getting close to it. There's going to be two basic ideas behind your base case. The first base case is going to be if you were looking at a cell that is 0, just you're done, right? There's nothing left to do. So, right, once we get into it, base case 1, if cell is 0, stop recursion. This is the idea that once we get to here, right, once we extend past that cell, we don't need to check any further for things part of this blob, right? Like there's nothing left after we get to here.
Oh, okay.
Now, what's the other base case though? Zach just said that once we get to 2020, something happens. One of the things that we're going to see is our recursion is really going to be recursively calling blobs. I need to make a bunch of arrows in all directions.
Oh, okay.
Right, we're gonna call a recursive blob in all 8 of the directions from our central blob.
So all this is doing is you're iterating through every blob, and as soon as you find a 1, then recursively check everything around it.
Yes.
Oh.
Yeah, and so like.
And you can't do this with iteration?
You have to do a bunch, and when I say a bunch, I mean a bunch of iterative loops. You would end up having like a quadruply nested loop in order to do this recursively. Because essentially you have to start at 0 0, work your way left to right, top to bottom, and then when you get to a thing you want to detect, then you have to start another doubly nested for loop that goes both left, right, and down for that loop. And the problem becomes how do you determine if you have some kind of like circle blob, right? Like think about iteratively determining if that is a blob or not, and then worst case, figure out if those are 2 blobs. It turns out it gets complicated if you try to do it iteratively. In this case, the recursion is actually potentially more
easier to understand.
Yeah, is more easy to handle. There is a way that you can do this in 2 passes iteratively. It's basically like a 2n squared thing where you go through and you can figure out the blob identifications from basically top to bottom and left to right, identify them, but the problem then becomes you'll have some disjointed blobs, and then have another iterative step that goes through and checks bottom to top and then right to left. So you go through going from this top corner.
Check diagonally.
Say it again.
It doesn't check diagonally.
Well, I don't want to get too sidetracked on the iterative solution just because it's not going to be too helpful. The short answer is it's complicated. Yeah.
Okay.
So let's think about this really quick. We're starting. I know I got a lot of arrows on this one cell. We start on this one cell. We know there's a 1 here. Which of these recursive calls is going to be fruitful, right? Which of these are going to keep going?
Scott, can I ask
Yeah,
one
of course you
question? The top 4 arrows, the one on the one that goes left to and the top, because we've already looped through until we find the first.
This is a good
one.
question. The answer is it depends a lot on how you handle everything else. Your intuition is correct, right? Based on my example that I just did, we've essentially checked all of these rows and we've checked that row. Right? So yeah, you're right that we don't really need to check those. The problem becomes what happens in this case right here, right? If you start checking, no, don't do that. If you start checking this cell, right, it's not going to detect anything here, right? It's only going to detect something to the right. So it'll go to the right. Then from here it'll go to the right. Then it'll go to the right. Then it'll go down. When it goes down, it needs to keep going down. And now here it needs to go left. Then here it needs to go left, and here it needs to go left, and then here, this is the catch, you need to go up.
Okay.
So you're right.
Because we're calling recursively, so we need the 8 directions.
Yes. Because you don't know if you're starting at the top right, or if you're starting at the top middle, or if you're starting at the top left, right? You don't know where you're starting in the shape. So yeah, your intuition is correct, but it turns out it gets a little complicated. But for right now, these arrows that we're going to spawn, right? All of these arrows are going to, right? They will all return back empty, right? Those aren't going to go anywhere. They'll go to the algorithm. They're going to come down here. There's going to say, is there something to check here? The answer then is no. Return -1.
Okay.
Right, so these 5 arrows all return -1. These arrows, though, they keep going, right? So then this arrow is going to essentially have. Well, I'm just going to duplicate this screen. We're going to do the same thing now. Oh, come on, mouse. We're going to do the same thing, but now here, right? And this arrow now technically is going to go. Right, it is actually going to check. It is going to go up, but you're going to have a different base case that's going to catch to make sure that it doesn't keep going. Now, in this case, this one is going to be, it'll return back nothing. Right, and then if we keep stepping down, we'll see that some of them will keep going. You want to make sure that this recursive loop doesn't go infinitely, right? That you don't go from this top cell into the bottom cell, and then the bottom cell into the top cell, and the top cell into the bottom cell, right? You don't want to go infinitely. You also don't want to form a loop that you could get into like here, where you start at this top corner, you go right, you go right, you go right, you go down, and then eventually you come back up, and you should know to stop at this point.
Okay, so like you set up like an if statement.
Probably what you want to do is you want to have a second grid that is determining like what you have found so far. And if you have already assigned a label to a blob, you don't need to recheck it. And I know that's a little bit of a big jump. So do you guys want me to outline that really quick? Yeah, okay. So let's go under this assumption. Oh man, it's like rain snowing outside right now. All right. So I'm gonna take this and just make it a little smaller. Yeah, I don't. Oh, it's because of that. Sometimes PowerPoint, you're the worst. All right. Who Who is not cooperating? Okay, we're just gonna deal with the fact that this is a misshapen cell. That's all right. So we're gonna have this table, and we're going to copy this table into another space. Hopefully, it will let me. Oh my gosh, PowerPoint. What did I just say? Thank you. All right, so this one is gonna start empty. Oh gosh, or it's gonna move. There we go. It's gonna start empty. So we're gonna check here, nothing. When we see that that's nothing, we're gonna want to put a 0 in that space. We check here, nothing. Put a 0 in, right? You see the pattern emerging: 0, 0, 0, 0, 0, 0, 0, 0. All right, we get here and we notice that there is something we want to detect. So right here is going to be something that you need to figure out. You're gonna have to have some kind of numbering convention. You might want to start at 2 instead of starting at 1. So for right now, I'm going to assume that we've figured out how to pass the indices through our recursive call. So I'm going to say we're going to start at index 2. So I'm going to put down a 2 here, right? We've detected a 1. It isn't detected here, so I'm going to put in a 2. At this point, I'm going to recursively call all 8 directions. And let's pretend for right now I'm going to start at the top left corner and work my way clockwise. So the first recursive call is going to check here, nothing, return base case, nothing. Base case, nothing, base case, nothing. Great, we get here. When we get to this cell, we want to then mark it as index 2. So we put a 2 there, and now it is going to have a recursive call that's going to check here, nothing, nothing, nothing. It'll get here. It'll notice that something needs to go here. It'll put down a 2. This one is then going to call nothing, nothing, nothing here, 2. Great. This one is then going to call nothing, 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 nothing. And then it's going to check its neighbor, which it doesn't actually know is the neighbor that it got called from, but it'll come down here and check here and see, oh, it's already been identified. I can return back the number, which in this case is 2. That will then collapse this node's recursive call. We'll come back to this node's recursive call, which then is going to check here, nothing, check here, nothing, check here, something, and then it's going to put a 2 here. Now we're at this spot. This spot is going to check here. We know that we've detected that. It's a 2. Same, same, nothing, nothing, nothing. It'll put a 2 here. Now, this one is going to call recursively nothing. Interestingly, we haven't actually detected this one yet, so we're going to mark that as a 2. We check here. It's already been checked. We go here, nothing, nothing. Here, we need to put a 2. When we go here, now we're going to check here, nothing. We've already checked the one above it, right? Do you see the pattern that's emerging? Cool. Okay. I don't want to go too much deeper into it because it's a lot of like handwork going through it. But the whole idea is that you want to identify, what do I want to do if I know that I need to put a mark here? Right? The first thing you need to do is you need to mark it in this output grid. And the second thing you need to do is you need to call recursive function calls to identify all the things that are its neighbors.
If it's already marked with something, well, in this case 2,
Yeah.
it will just collapse on
Yep.
itself.
And so you might want to pre-fill this array with -1s, right? Or just something that's not a number that you're going to use for identification. Because then you get to know both, oh, I've already checked this, and you will know, oh, I've already assigned this to be some blob number. Is this helping?
Yes.
Okay. So again, don't think too long about. I don't want to say don't think too long. Use abstraction in this problem. If you think too much about like, oh, I'm going to go here and then that goes there and then that goes there and then that goes there, right? You essentially are going to solve the whole grid, and that's too much. You want to parse this down into an individual step, which is, what do I do if I've determined, for example, this one, If I've figured out that I need to go somewhere from this node, what do? Well, I need to identify what its index is, and then I need to check all of the indices around it. And then that's all, right? That's the only thing that the recursive function is doing. And then the recursive nature of that will then lead to all of these ones being detected.
Makes sense to
Cool.
me.
Okay. Ryan, you okay?
Yeah.
Zama, does that make sense? You okay with that? Okay, cool. Josh, doing okay? I know your mic's muted. That's okay. You also might be doing something else. All right, so cool.
Good.
No, that's all right. That's all right. I appreciate the etiquette of muting a mic. So the next question gets into how do we think about the complexity of this? And the complexity is complicated. I would suggest approaching that calculation based on best and worst case scenarios. Right, like worst case scenario is going to be that you have the maximum number of possible blobs in a field that are all unique to each other or from each other. Best case scenario is probably an entire field full or an entire field that's entirely empty. Right, if there's no blobs to identify, then it's just an n squared problem.
Wouldn't that just be 20 by 20 by 8, roughly?
Oh, yeah,
Because you're
maybe. This gets into like, what do you mean when you say n?
well, n is the size of your board, I guess.
Yeah, well,
I guess that could be two different things.
it's the size of one edge of your board, right?
Right. So it's not really. Well, you can't really say n squared because if the board's not square, then you could have like a 20 by 30 or something.
That's a good point. Yeah. So it's m by n, and if m and n are similar, then it's n squared, right? You're right. The way you're thinking about it is correct, but I don't want to get too in the weeds there. So if you have a board that's like this, right? It's a field of nothing. You don't actually need to check the neighbors of each cell.
Oh, like if it's a 0.
Yeah, like if it's a 0, I just see it's a 0 and I don't need to do anything. So in that case, it would be n squared. Right, assuming we're talking about square boards. However, if we have ones in everything, I'm not actually going to go through and put ones in everything, right? If we have ones everywhere, then yeah, we probably are in that n squared times 8. Because every single one of these nodes... Well, actually, no. Let me think about that.
Isn't that still n squared, though, if it's just 8 times
no,
n squared?
it's... Well, actually, it's not even that. It's just going to be n squared... Well, n squared... It'll be n squared plus n squared. Maybe. Well, let's think about this for a sec. Our iteration leads to the n squared because we have to iterate over every single cell by row and then by column. Once we identify a single point of a blob, detecting that blob is going to be a... I'm going to change. Let's call it a b. It'll be b times 8, right? You'll have to check the number of elements in that blob. Does that make sense?
Mm-hmm.
And every single time you check one element, you're going to have to check its 8 neighbors. So that's where I'm getting that 8 times b number from.
Right. Yeah, I get that, but I feel like at the most you're checking every element. Like every single element, you're only checking it once at some point in time.
Correct, yeah.
So there's only 8 for every, like, worst case is every single element, you're checking all 8 things around it, obviously excluding the edges.
Yeah, worst case is like you have a blob with a single element. Well, not even, right? Because that's like the same, but that's the same as that, right? There's not really that much of a difference between let's say like that. No, 11. Hey. Right, the difference between checking these 3 cells and checking these 3 cells is pretty minimal in terms of our complexity.
Mm-hmm.
because when our outer loop, our n squared loop, is going to get here, it'll call 8 function calls. One of those function calls will call 8 function calls, and one of those function calls will call 8 function calls. Over here, this one is going to call 8 function calls, and this one is going to call 8 function calls, right? But from a complexity standpoint, they're very similar.
Mm-hmm. Yeah, so it's just n squared.
Yeah, I'd probably call it n squared. And now the important thing here is that the both in the 8 queens problem and in this blob problem, the notion of assigning a complexity is, well, it's difficult, and that's why I asked the question, is because it's not intuitive. We've been thinking, throughout the semester on like, okay, if I want to insert to the front of a vector, I need to shift everything down. That's n operations. Okay, that's easy, right? That's pretty straightforward to get to. But in practice, this is going to be more like what you will do when you're thinking through, well, how many times am I doing this kind of iterative loop? How many times am I going through and, checking these things? And that's a lot more nuanced most of the time, and it's a lot more dependent on what your problem space is.
Mm-hmm.
Yeah, I don't know if that's helpful.
That makes
Okay.
sense.
Cool. All right, that's 8 queens and blob detection stuff. Samira, how are you doing? Oh, Samira's mic's off. That's all right. Hopefully she's okay. If you got issues, you can get in the chat or email me. All right. Other questions, comments, problems? I want to be respectful of your guys' time too.
Are you going to be updating this PowerPoint?
I can updating it or uploading it.
Like, I realized that what the PowerPoint that you were using was already updated, uploaded on Blackboard.
I just grabbed the walkthrough that I posted a little bit ago.
Yeah.
Yeah, I can post these couple of slides. I don't think I want to put too much more work into them, but yeah, I can upload these.
Yeah. Just what you wrote down for this.
Not a problem.
Session.
Not a problem. Cool.
And you'll be posting this video sometime today?
Oh, it'll go up as soon as we're done with it.
Oh, YouTube.
Yeah.
Does
Like technically, I think right now you can actually go back and listen to the first couple of minutes. Right, you can rewind.
Oh yeah, I
and
can.
we'll get all that figured out too. Right, that's if you want to access it and you can't find it, I need to find a better way for you to find it. So let me know and we'll figure it out. I think what I'll probably end up doing is I'll make a new chat session for every lecture, and then I will pin the YouTube link to that chat session, so you can always find the link back to that YouTube for that chat. I think that's going to be the path going forward.
Okay.
Yeah. And again, if there's something you're like, hey Scott, you should really try this, let me know, right? Because we can play around with that. Well, all right, we're approaching our kind of arbitrary time limit, but I can keep talking if you guys got more questions. But at the same time, thank you all for kind of testing this out with me and seeing how it works. I appreciate it. It's I think we're going to be good to go starting on Monday.
Are you meeting on Friday?
We can. I'll probably be available. We might not make it as formal as like putting up a stream, but I'll be online certainly if you got questions or if you want to talk.
Okay.
Yeah, I would say make it what you want. Yeah. Anything else?
I got one more general question.
Go Josh.
Oh, I was just saying, are you free after?
Oh yeah. We can chat one-on-one. Yeah, no problem. Ryan, were you say something?
Is there going to be like leniency with this project due to this insanity that has been going on?
Maybe. We'll see.
Okay.
I mean, it depends on what you mean by leniency.
I'm not talking about like insane amount, just like a tiny bit of like extra consideration with
for sure.
With it going on.
And I know that like you were saying you were having a hard time getting Visual Studio Code up and running, so that was a fair amount of time, not just the actual work of the project. Yeah, we'll figure that out. I don't want to
Okay.
say like, oh, there's no due date, or right, you can turn in whenever. I want to keep that due date firm, but yeah, we'll figure it out.
Just keep in contact with you about
Yes.
stuff that's happening
Yes.
with
Yeah.
it. Okay.
To your immediate question, will there be leniency? Yes, absolutely. Right. But at the same time, you got to let me know what's going on in order for me to try to help and to try to figure out what's going on. The other thing we got to figure out, and this might be a thing we talk about on Friday, is what we want to do about the test. I have a couple of options for you guys in terms of, man, I'm leaning towards even like getting rid of all the tests for the rest of the semester. But I want to leave that up to you guys in terms of how that will change the grading for the class. I'll send out more information about it throughout the week, and we'll probably talk about it either Friday or on Monday. But yeah, I want to make sure that you get the most out of the course, not that we fully replicate what we were going to do in this like virtual space, if that makes sense. So,
Yeah, that makes sense.
well, all right. Unless there's anything else, I'm going to stop this stream and I'm going to jump in with Josh and see what he's got going on, and we'll talk later. Feel free, even outside of normal class time, you can at either Professor or at Scott in the Discord chat, and you'll get my attention, and I can jump in and help out.
All right.
Cool. Well, again, thank you guys. If you got any problems or questions, let me know.
Okay.
Cool. All right. We'll see you guys later. I'm going to stay in the stream, but if you guys want to peace out, you can.
Okay.
Okay. All right, Josh, let's get this stream stopped.
Okay.